right, so I'm going to revisit this copy problem. It says a particular professor noticed that the number of people, P, who complain about his attitude depends on the number of cups of coffee that he drinks, N. Okay, so the P is the dependent variable, or sort of the Y variable. Cups of coffee, N, is the independent variable. All right, so I think this format isn't kind of confusing some people, this P with the parentheses. All this means is that P, the number of people that complain, is a function or depends on N. All that means is that the variable that's in the linear equation is N. As N changes, P changes. So it's just a different way of writing the same equation, but it just means that P depends on N. That's it. So don't let that get you confused. All right, let me go into Lumen. And so it wants us to come up with the regression line. So in order to do that, it just means that we need to go into Rossmann chance. So let me go into Lumen real quick. So I'm going to cut and paste my data. I'm in Lumen. I'm going to do copy. Then I'm going to go into my Rossmann chance. The first thing I'm going to do is clear my data. Then I'm going to paste my data from Lumen, and I'm going to click Use Data. I want to make sure that this value here matches how many sample points I have, which is 8 pairs. Then I'm going to come over here and I'm going to click Show Regression Line. That is going to come up with the line, the equation of the line to estimate the response variable, or P. All right, so let's go back here. I already have that in my presentation. And so we have down here, here's my estimate line. P equals 13.54 minus 1.73n. So that is my form, the number of people that complain. This is my y-intercept. This is my slope, okay? Even though it didn't ask, let's interpret the slope. I always like to write the slope as a fraction. So I take the sign with that coefficient, negative 1.73 divided by 1. Slope represents change in y over change in x, okay? Or in this case, change in p over change in n. So as cups of coffee increase by 1, the number of people that complain decreases by 1.73, or decreases about 2. All right, that's how I would interpret the slope. This here says use regression to find a linear equation. Well, all you had to do was put it into Rossmann chance. This equation right up here is what it's asking for. The reason it's saying it like this with n is instead of writing x here, it wants you to put n in. So P, the number of people that complain, depends on n, the number of cups of coffee. 13.54 minus 1.73 times n. That's all it wants. It just wants you to pull that regression equation from Rossmann chance. The second part says, how many cups of coffee should he drink so that no one complains? We need to figure out which thing we're solving for. How many cups of coffee? We don't know. Cups of coffee is represented by n. Should the professor drink so that no one complains? Complains is represented by the variable p. If no one complains, p equals 0. So we're just taking this equation here and we're plugging in what we know, which is p. P equals 0. All right, 13.54 minus 1.73 times n. We want to solve for n. Okay, if we simplify, if I add 1.73n to both sides, that gives me this 1.73n, right? That reduces out, is equal to 13.54. Okay, so now we still need to get n by itself. How are we going to do that? Well, I'm going to divide both sides by 1.73. I want that to reduce, so now I'm left with n is equal to 7.82. N represents cups of coffee. This is 7.82 cups of coffee, so that 0 people complain. How many cups of coffee? Well, we want to round to 1 decimal place. 7.8 cups of coffee. Again, we just took that regression line from Rossman-Chance. Let's do another example. This one is the relationship between poverty rate Y, okay, that's my y-axis is the vertical, and high school graduation rate X, that's my horizontal axis. So this is telling us that we did a linear regression, meaning we already put it into Rossman-Chance, and it gave us this regression line. This regression line is going to estimate, poverty rate is Y, equals 64.68 minus 0.62 times X. X is high school graduation rate. If I put it in words. All right, so it tells me the actual high school graduation rate is 91.9%. The actual poverty rate is 7.402%. What is the residual? Well, let's first write this as an ordered pair, or just connect sort of all the different ways we can write it. We can write it as an ordered pair. Actual, we always write X, Y. High school graduation rate, poverty rate. In this case, our high school graduation rate, our X, was 91.9%. Our Y was 7.40% poverty rate. So when the high school graduation rate was 91.9%, the poverty rate was 7.04%. What is the residual? Well, the residual just is telling us how far away the actual rate is, in this case poverty, how far away that is from what the line predicts. We just want to know how well will the line predict poverty rate. So residual is actual Y rate, okay, minus the estimated or the predicted. So to get the estimated rate, we need to go and we need to use this equation. That's going to estimate. Y hat is equal to 64.68. Just took this equation right here, minus 0.62 times X. Note, we're using the same X. We're using the same X, 91.9. We just substitute that in, and when we multiply, the line is predicting 7.702 poverty rate. So the residual just takes the actual minus the prediction that we get from the line is equal to, don't lose this negative sign here, is negative 0.317. So that's the residual, negative 0.317, meaning that the estimate was bigger than the actual. The estimate was bigger than the actual. So let's interpret that. Well, what does that mean? It means that the prediction, it's saying, did it overestimate or underestimate? Well, it overestimated. This one's sort of counterintuitive because you have this negative sign here. It just means if you look here, our actual is below the line, Okay, actual minus estimate. So it overestimated. How much did it overestimate? By 0.317. So to interpret that means that the prediction overestimated poverty rate by 0.317%.